Look at your arm. Not your face. Not your reflection. Just your skin. Whether it's pale enough to burn after 20 minutes in the sun or dark enough to shrug off hours of sunlight, that color is carrying a message. A message written over hundreds of thousands of years by one force that has never cared about politics, culture, or identity. The sun. Every shade of human skin on Earth exists because your ancestors spent generation after generation negotiating with a giant nuclear star 93 million miles away. And here's the part almost nobody realizes. Your skin wasn't designed to make you look a certain way. It was designed to solve one of the deadliest survival problems our species has ever faced. 300,000 years ago, there was no such thing as white skin. None. The first Homo sapiens evolved in Africa, where sunlight is among the strongest anywhere on Earth. Every human alive today, whether they're from Norway, Nigeria, China, or Peru, can trace their family tree back to people with dark skin. That wasn't a coincidence. It was survival. Imagine living your entire life under an unforgiving tropical sun. No sunscreen, no sunglasses, no air conditioning, no shelters with UV-protected windows. Every day, your skin was bombarded by invisible ultraviolet radiation. You can't see it. You can't feel most of it. But your cells can. UV light tears apart DNA, damages living tissue, and quietly increases the chances of deadly mutations. The sun wasn't trying to kill our ancestors, but biology doesn't care about intentions, only consequences. Fortunately, evolution had already invented a remarkable defense. Melanin. Most people think melanin is simply what gives skin its color. That's like saying steel is simply what gives a bridge its color. Its real job is protection. Melanin absorbs dangerous ultraviolet radiation before it can penetrate deeper into the body. The more melanin your skin produces, the better your natural protection becomes. Under the African sun, this wasn't just useful. It was essential. Generation after generation, people with more effective UV protection were more likely to survive, raise children, and pass on their genes. Slowly, over thousands of generations, dark skin became the standard human condition. But DNA wasn't the only thing melanin protected. Hidden inside the bloodstream was another molecule that would change the course of human evolution. Folate. Folate is a form of vitamin B9. You probably know it from pregnancy supplements. But long before pharmacies existed, it determined whether many pregnancies would succeed at all. Early in pregnancy, folate helps build the developing brain and spinal cord. Without enough of it, embryos often couldn't develop normally. Here's the problem. Ultraviolet radiation destroys folate. Every hour beneath intense sunlight slowly reduced the body's supply. For people with less melanin, that loss could become significant. The result wasn't simply illness. It was fewer surviving children. Evolution doesn't reward effort. It rewards successful reproduction. Dark skin became one of humanity's greatest biological shields because it protected both our DNA and the next generation. Two completely different problems. One elegant solution. Then humans did something evolution hadn't prepared for. They left Africa. Not all at once. Not as one great migration. Families simply wandered farther than their parents had. Then their children wandered farther still. Over thousands of years, humans reached the Middle East, Europe, Asia, eventually every continent except Antarctica. And with every step north, the sun changed. Not because the sun became weaker, because the Earth changed its angle. Sunlight had to pass through more atmosphere before reaching the ground. Much of its ultraviolet energy disappeared along the way. Suddenly, the same skin that had protected generations in Africa faced an entirely different challenge. There wasn't enough sunlight anymore. This created one of evolution's greatest trade-offs. Humans still needed protection from UV radiation, but they also needed something that could only be made using UV light. Vitamin D. Your skin is far more than a protective covering. It's also a chemical factory. When ultraviolet light strikes your skin, it begins a chain reaction that produces vitamin D. Without enough vitamin D, the body struggles to absorb calcium. Bones weaken. Children develop rickets. Adults suffer fractures more easily. Women face more dangerous pregnancies because the pelvis doesn't develop normally. In northern climates, vitamin D deficiency wasn't just uncomfortable. Could become fatal. Now imagine having very dark skin in an environment where sunlight is already scarce. Your natural sunscreen works almost too well. The little ultraviolet light available struggles to penetrate deeply enough to produce adequate vitamin D. The adaptation that once saved your ancestors had become a disadvantage. Evolution noticed. Random mutations occasionally reduced melanin production. Most mutations disappear. These didn't. People with slightly lighter skin absorbed a little more sunlight. They produced slightly more vitamin D. Their bones were healthier. Their children survived more often. The difference wasn't dramatic. It didn't happen in one generation or one century. It happened over thousands of years. Little by little, shade by shade, until entirely new populations emerged with much lighter skin than their African ancestors. Not because lighter skin was better, because in those specific environments it solved a different problem. Evolution hadn't changed its goal. Only the rules of the game had changed. For decades, scientists believed this process happened gradually. Ancient DNA has revealed something far more surprising. Many of Europe's earliest hunter-gatherers still had relatively dark skin long after arriving there. One of the most famous examples is Cheddar Man, who lived in Britain around 10,000 years ago. Genetic analysis suggests he likely had dark skin, dark hair, and blue eyes. To modern audiences, that combination seems almost impossible. But only because our expectations were built by today's populations, not ancient ones. The very pale skin common across northern Europe today appears to have spread surprisingly recently. Why? The answer wasn't another ice age. It was farming. When humans became farmers, everything changed. Hunter-gatherers ate fish, game, organ meats, foods naturally rich in vitamin D. Farmers relied much more heavily on grains, wheat, barley. Their dietary vitamin D collapsed. Now the body depended far more on sunlight alone. Suddenly, producing vitamin D efficiently became even more important. Natural selection accelerated. Mutations for lighter skin spread through farming communities generation after generation. Agriculture didn't just transform civilization. It transformed the appearance of millions of people. Perhaps the most fascinating discovery is that evolution solved this problem more than once. Europeans and East Asians both evolved lighter skin, but they often did it using different genetic mutations. Different populations reached remarkably similar solutions independently. Biologists call this convergent evolution. Nature kept solving the same problem because the pressure was so strong. When evolution repeatedly invents the same answer, it's usually because there aren't many alternatives. Today, skin color carries enormous cultural meaning. Entire societies have built identities, hierarchies, prejudices, and histories around it. Yet biologically, skin color is astonishingly simple. It's a calibration system, a living record of how much ultraviolet radiation your ancestors needed to block, and how much they needed to absorb. Nothing more, nothing less. If your ancestors lived near the equator, darker skin protected them. If they lived beneath cloudy northern skies for thousands of years, lighter skin helped them survive. Both were brilliant solutions to different environments. Neither is the default for the modern world. Both are masterpieces of adaptation. The next time you step into the sunlight, remember this. The color of your skin isn't an accident. It isn't a mistake. It isn't a random feature inherited without purpose. It's one of evolution's oldest survival technologies. A biological memory stretching back hundreds of thousands of years. Every shade of human skin is the result of countless generations facing the same question under the same sky. How much of the sun can we survive? And every population answered it differently. Not because they became different kinds of humans, but because they all remained the same remarkable species, adapting to a changing world.